So today we are going to be proving that the properties of a parallelogram is enough to prove that a quadrilateral is a parallelogram. So the definition of a parallelogram is a quadrilateral that has two parallel sides. Now yesterday we proved what all the properties of a parallelogram were. Today we're going to prove that these are enough to go backwards and say that this is a parallelogram. So if we were to draw a parallelogram, we'll name it parallelogram math. We will assume one of the properties of the parallelogram. Let's assume that opposite sides are congruent. So MH is going to be congruent to AT by the given, and we are going to also assume that MA is congruent to HT by the given. Is this enough to prove that the opposite sides are parallel? Well, the first thing we're going to do is we're going to draw a side MT and say MT is congruent to MT by the reflexive property. Which makes the two triangles congruent by SSS. Again, I'm not trying to write a formal proof here, I'm just trying to give you the information you need in order to see that the two pairs of sides are parallel. So that will make angle MTH congruent to angle AMT, and that will also make, which implies that side MA is parallel to side HT by the converse alternate interior angle theorem. So the angles are congruent by CP/CTC, and the sides are parallel by the converse alternate interior angle theorem. We can do the same thing for the other angles as well. So that would make angle ATM congruent to angle HMT, which makes their lines congruent by the converse of the alternate interior angle theorems as well. So what we've just done is prove that knowing that only that the opposite sides are congruent, that the lines are parallel. So that shows that this is enough information to prove that a quadrilateral is a parallelogram. So, sorry guys, my nose is running, so let me restart this for the next property. The diagonals bisect each other, so we're going to draw a parallelogram. Let's call it PART, because why not? If we're told that there are two diagonals and they bisect each other, we'll call this point here M, and we're told that PM is congruent to MR and MT is congruent to AM. This should be enough information to prove that the opposite pairs of sides are parallel. So the way we're going to do that is by proving that there are several congruent angles, so that we can show that the lines are congruent by the converse alternate interior angle theorem. So firstly, we would say that this angle and this angle are congruent by vertical angles, which makes this triangle, triangle 1, congruent to this triangle, congruent 2, by SAS. That should be enough information to show that angle P is going to be, or this part of angle P is going to be congruent to this part of angle R by CP/CTC, which will prove that side RT is parallel to side PA. We can then do the same thing in the other triangles by saying these angles are congruent by vertical angles. We get that triangle 3 and triangle 4 are going to be congruent by SAS. And then we can say that this part of angle T is going to be congruent to this part of angle A, making these sides parallel by the converse alternate interior angle theorem. So this also is enough information to prove that a quadrilateral is a parallelogram. Can we do it with the adjacent angles being supplementary? Let's find out. So if we have a quadrilateral ABCD, and we're told that x plus y is equal to 180 degrees, that makes this angle x and this angle y as well. So x plus y equals 180 is given. We can say that AB is parallel to DC by the same side interior angle theorem. So that's already proving two of the sides are parallel. We can also say that we can use our two parallel lines of AD will be parallel to BC. Oh, well, we're told that the angles are supplementary, so this is actually the converse. So these are parallel by the converse. Same side interior angle theorem. So knowing that the consecutive angles were supplementary gives us the information we need to use same side interior angles, which proves parallel. Next we're going to work, so these being supplementary gives us enough information to state that the pairs of opposite sides are parallel. So we have one more to do, and then there's going to be a bonus one. We'll just stick with ABCD. So if we know that opposite angles are congruent, that would make angle D congruent to angle B, and angle A and C congruent as well. How are we going to prove that these are parallel? Well, do we have what we need in order to do this? So because a quadrilateral is the sum of the angles adds up to 360 degrees, we can say that angle A plus angle B plus angle C plus angle D is equal to 180 degrees. And because we know that A is equal to C, we can replace the C with an angle A using substitution. And because we know the angle D is equal to B, we can replace that with angle B using substitution. So we get 2 angle A's plus 2 angle B's are equal to 360 degrees. By division, we can say that angle A plus angle B is equal to 180 degrees. So that makes these supplementary. And by substitution, we can say angle C, which is equal to angle A, plus angle B will equal 180 degrees, which is supplementary. So that means because these are supplementary, that makes AD parallel to CB. And because C and B are supplementary, that makes DC parallel to AB. And that would be the final way to show that this is enough information to prove that the quadrilateral is a parallelogram, just knowing that the opposite angles are congruent. Now there is one more property that we didn't discuss the other day. We will go over it here really quickly. So the final property is that one pair of opposite sides are parallel and congruent. This is enough information to prove that a quadrilateral is a parallelogram. So let's try that. So we have a quadrilateral, and we're told that this side is congruent and parallel to this side, A, B, C, D. So we will draw a diagonal. Because the sides are parallel, that makes these angles congruent. This is a reflexive side, and that gives us SAS, proving that this side is going to be congruent to this side by CPCTC. And this angle is congruent as well by CPCTC, which proves that this and this are parallel. So with all 5 of these properties of a parallelogram, you can be guaranteed that a quadrilateral is a parallelogram. So if we take a look at the assignment today, we are looking to see if a quadrilateral has those properties. If it does have those properties, it has enough information to prove it as a quadrilateral. If it doesn't contain those properties, then it doesn't have enough information. So like this one might be unclear, but what you see here is that we have a pair of supplementary sides and a pair of supplementary angles as well as a pair of congruent sides. So these actually tell you that these are parallel and congruent. Therefore, we have enough information to prove that it is a parallelogram.